Assalamu alaikum. Welcome to DSP lecture. My name is Iman Rahman and my enrollment number is 17TE98. In today's lecture, we will discuss what is system, the basic operation that we can perform on a system, and what is zeroth, first, second order whole, and what is even or decomposition. So start from the system. What is system? System is defined as a process to produce or create other signal. It means we have some signal and we perform some function on it, and then we get an output. For example, here we have an input x of n passes through a system and we get an output y of n. If we consider y of n is equal to 3 times of x of n, it means that our input x of n passes through a system in which it got multiplied by a factor of 3, and we get an output y of n which is 3 times of x of n. Now we will discuss the basic operation that we can perform on a system. First is inverse, then the scaling, and we can compress and expand our system. First we will discuss inverse. Inverse is also known as flip or mirror. All these three words are same. If we have a system of y of n which is equal to x of minus n, it means that we have an input of x of minus n passes through a system and produces an output of y of n. What type of an output? That it will take all the values of input and flip them and produces an output of y of n. For example, if we have an x of n equal to minus 2, minus 1, 0, 1, 2, 6, 3 and 4, and we have to find the inverse, means we want to find x of minus n. Then what we will do, we will flip all these values toward right side around 0 and all these values toward left side around 0. Then our x of minus n will be 4, 3, 6, 2, 1, 0, minus 1, minus 2, and this represent our 0 index value. We will also find inverse by putting values in this system. Like if we want to find the value of y at 0, then y of 0 is equal to x of minus 0, which is equal to x of 0. So x of 0 is 0. If we want to find the value of y at minus 3, then our x will be of minus 3 minus into minus 3, which is equal to x of 3, and x of 3 is equal to 6. So y of minus 3 is equal to 6. Here at minus 3 our value is 6. So we can find value by direct flipping them around 0 or by putting values in a system. Next operation that we can perform on our system is scaling. There are two types of scaling: amplitude scaling and the index scaling. Amplitude scaling. In amplitude scaling, we just multiply our signal with any factor. For example, in this case, y of n is equal to 2 of x of n. We just multiply x of n by the factor of 2. For example, if x of n is equal to 3, 2, minus 1, 2 and 1, and this is our 0 index value, then we will get a y of n by just multiplying all the values by 2. Then y of n will be 6, 4, minus 2, 4, 2, and this is our 0 index value. Index scaling. Index scaling is also known as compression. It just compresses our signal. For example, in this case, y of n is equal to x of 2 of n. This factor show how much we will compress our signal. In this case, we will compress our signal by the factor of 2. For example, x of n is equals to 2, minus 1, 0, 3, 1, 2, 3, and this is our 0 index value, and we want to compress this signal by the factor of 2. And then we can find the value by just putting the values in this equation. If we want to find the value at 0, then y of 0 is equal to x of 0. 2 multiplied by 0 give us 0. Then x of 0 give us 0. So y of 0 is equal to 0. At 1, then y of 1 is equal to x of 2, and x of 2 is equal to 1. So y of 1 is equal to 1. And if we want to find the value at 2, then y of 2 is equal to x of 4, and x of 4 give the value of 3. So y of 2 is equal to 3. Then we in the same way we can find the y of n, which is equal to 2, 0, 1 and 3. Last operation that we can perform on our system is expansion. If our system or a signal is divided by any factor, it means that that system or that signal is expanded. For example, x of n is equal to 2 minus 1 0 3 minus 1 1 3, and this is our zero index value, and we want to expand it. Then we will find our expanded value by putting the values in this equation, and then y of 0 is equal to x of 0, which is 0, and y of 1 is equal to x of 1 by 3, and there is no value at 1 by 3, so this will be discarded. Y of 2 is equal to x of 2 by 3, and there is no value at 2 by 3, so this will also be discarded. At y of 3, x will be equal to 3 by 3, which is equal to x of 1, and at x of 1 is equal to 3. So it means that our system is expanded by a factor of 3. So y of n will be equal to 2 0 0, then minus 1 and 0 0 0, and this is our zero index value, then 0 0 3 0 0 minus 1 0 0 1 0 0 3. So in this way we find the expanded form of y of n. Now we will draw our original signal, as our original signal is this, and we have just plotted at 2 we have a peak of 2, and at minus 1 we have minus 1, and at 0 we have 0, and so on. We just draw our original signal. Now we have to draw our expanded signal. This is our expanded form, and we have to draw it. So this is our expanded signal, in which at minus 6 we have a peak amplitude, then at minus 5, at minus 4 we have a 0, and then at minus 3 we have minus 1, and then from minus 2 to 2 we have 0, and then we have a peak amplitude, and so on. Now we will discuss zero order hold, first order hold, and second order hold. First we will discuss zero order hold. For this we will consider our previous example. This is our zero order equation, this is our original signal, and this is our expanded signal, and we have to find the zero order of this signal. How we find the zero order of this signal? We will hold our previous sample value for the next 3 sample value, and then we got our next value, and then we hold that value for the next 3 sample. Why next 3 sample? Because our original signal was expanded by the factor of 3, so we have to hold our previous value of that sample for the next 3 sample. Means we hold this value for the next 3 sample. Next 3 sample means we hold this value 1 sample, then second sample, then third sample. At this point we got our next value. Then again we will hold this value for the next 3 sample, and then we got our next value, and so on. In first order hold, instead of joining at each point, we just meet our peak values. From 3 to minus 1, then 0, then 3, then minus 1, then again 1, and then 3. In this way we can reread our original signal, or we can say that we can recover our original signal, and we can also see that our first order hold is very much similar to our original signal. So we can say that by using first order hold we can reread our original signal at receiver side. Second order hold, we will consider this signal and we will find second order for this signal. For finding second order we have to find the first order, and how we find the first order, we will take the derivative of this signal, and then again we will take the derivative of signal, then we will got the second order of this signal. For first order hold, we will take the derivative. As I say that we will take the derivative, and how we take the derivative? We take the derivative by taking the difference between 2 points. Means for finding the value at 1, we will take the difference between this point and this point, which is 1 minus 0. So at 1 we have 1. For point 2, we will take the difference between this point and this point, means 2 minus 1, which is equal to 1. In the same way, we will find the value still point 5, but when we find the value at 6, it means we will take the difference between this point and this point, means 5 minus 5, which is equal to 0. So from onward, we will our signal will be dead, because our we have taken the difference between the same point, which give us obviously 0. So our signal become dead after 5. Now we will take the derivative of this signal. How we take the derivative? In the same way, we will take the difference. For example, for this point, we will take the difference between this point and this point, means 1 minus 0, which is equal to 1. But when we find the value from 2 to 5, we will taking the difference between the same point, because our system will have a same peak from 1 to 5. So our signal will be 0 from 2, 3, 4 and 5. But when we are finding the value at 6, means we are taking the difference between this value and this value, means 0 minus 1, which is equal to minus 1. So at 6, we will have minus 1. So in this way, we have find the second order whole. We'll discuss the applications of basic operation, that if we want to perform these three operations, that is shifting, inverse, which is also known as flip or mirror, and scaling on a system simultaneously, then what we will do? If we consider a system of y of n, which is equal to x of minus 2n plus 3, and our x of n is equal to 1, 2, minus 1, 2, 0, 1, 1 and 3, and our 0 index is at minus 1, then what we will do? We will divide our system into 3 steps, and these 3 steps are shifting, inverse and scaling. And for shifting, we will consider our u of n is equals to x of n plus 3. And for inverse, we suppose that omega of n is equals to u of minus n, and for scaling, we will take y of n is equals to omega of 2n. We just divide our given system into 3 steps for our convenience. Now we will do shifting of our given system. For shifting, we consider the equation of u of n, which is equal to x of n plus 3. It means that uh, we just shift our 0 index to 3 steps. Means it in the given system, it is at minus 1. We just shift it and it become at 1. So our after shifting, our u of n will be 1, 2, minus 1, 2, 0, 1, 1 and 3, and our 0 index is at 1. Now we will do inverse. For inverse, we consider the equation of omega of n, which is equals to u of minus n. It means we just shift all these values toward this side around 0 index, and all these values toward left side around 0 index, and our omega of n will be equal to 3, 1, 1, 0, 2, minus 1, 2 and 1. And now we will do scaling. For scaling, we consider y of n is equals to omega of 2n. It means that we are just compressed our given system by the factor of 2. So after scaling, y of n will be 3, 1, 2, 2 and our 0 index will be at 1, and then we just plot y of n. Now we will discuss the even odd decomposition of a signal. For finding the even decomposition of a signal, we just need to know this formula, and then by putting values in this formula, we can draw the even decomposition of a signal. If we consider this signal, then by putting values, for example, for n equal to 0, then x of 0 is equals to x of 0 plus x of minus 0, which is equal to x of 0 divided by 2, and x of 0 is equal to 2. So 2 plus 2 divided by 2 equal to 2. For n is equal to 1, our equation will be x of 1 plus x of minus 1 divided by 2, means at x of 1 we have a value of 1, and x of minus 1 we have a value of 1. So 1 plus 1 divided by 2 equal to 1. In this way, we find the value at 2, at minus 1, at minus 5, and then we just plot them. It's according to you, it depend on you that how much sample you will take. I will just taking 5 sample and I just draw them here. Now we will discuss the odd decomposition of a signal. For odd decomposition of a signal, we just need to know this formula, and then by putting values in this formula, we can draw the odd decomposition of a signal. If we consider this signal, then we will put the values in this formula. For n equal to 0, the equation will be x of 0 minus x of minus 0 divided by 2, which is equal to 0, and for n equal to 1, our equation will be x of 1 minus x of minus 1 divided by 2 equal to minus 1. In the same, we will find the values at the other sample and then we plot them. That's all for today. Thank you so much for watching. Allah Hafiz.